Okay, I'm back, and so now we want to talk about some examples of molecules attaching to themselves and what happens. So the first one I wanted to mention is surface tension. So water wants to stick to itself, and it actually can form a film at the surface of water. So those water molecules are sticking together, and they can stick so hard they can actually act like a trampoline that a certain kind of insect can walk on top of. So that's a water strider. So that picture that's right next to it is a particular kind of insect, and as long as it doesn't break the surface tension, it can actually walk on the water as a result of that. Now don't do this, okay? But if you were to have a water strider and then you put a single drop of detergent onto that water strider will go right to the bottom. Okay, because what does detergent do? It breaks up surface tension, and then that's the reason why it's good for washing dishes and clothing with. Okay, the next one is that water sticks to itself, and let's say oil sticks to itself, but they don't stick to themselves with the same amount of force. So like for example, oil and maple syrup, it sticks to itself more than what water does. And so we're going to call this viscosity. So that if you were to take maple syrup and you pour it, it very slowly comes out because the molecules of the maple syrup are sticking to each other very hard. On the other hand, water is very runny. Well, who cares? Well, later in the course, we're going to talk about volcanoes. And so some volcanoes erupt very gentle, and the lava comes out and it basically just goes sideways. Then you've got other kinds of volcanoes that explode, and this is because of the viscosity. So if magma is not viscous, it tends to be runny. If magma is very viscous, it sticks to itself, and you tend to have these very explosive eruptions. So we'll talk about that later. And then another example is capillary action, in which the material, like the water, is sticking to something else. So like for example, if you've got a tube and then you've got some water in it, what will happen is the water molecules will stick to the sides of the tube, and then you have what's referred to as a meniscus. And so depending on how thin the tube is, that determines how high the material can go in there. An application of this is called chromatography. So that and this is something that you can do, take a regular piece of paper and then mark on it with a black ink pen. So make a mark on it, and then what I want you to do is take that piece of paper and dip it in some alcohol. Okay, so that you've got this piece of paper, and on that piece of paper you got this black dot. So all you got to do is put it in some alcohol, and the alcohol will start to climb the piece of paper, and then when it gets to that ink, it will start to separate the ink into the various pigments that are in the ink. So the different colors will rise in that piece of paper different distances. So you can try that. And this is really important because this technique can be used to separate different kinds of chemicals so that you can identify what were the chemicals in that particular thing. Well, I know that you're saying to yourself, what in the world does this have to do with minerals? So, in our next segment, we're finished with the chemistry, and now we want to apply that chemistry to minerals. So I'll see you in just a moment.